We are going to learn today. We are going to learn machine code generation for your instructions. Okay. Now in 8086 we are going to use 8086 assembly language. Yes, move AX, BX, add AL, BL like this. But your machines always understand only one language. 101010. That is binary or machine language. So we want to learn how your instruction of 8086 is getting converted into binary. So what it will do so that at the end of the day your microprocessor is getting binary values. Yes? Yes. So though you have written move AX, BX, what your computer gets is binary for this. Yes? And we know that in 8086 all instructions are of different size. Instruction can be of 1 byte also, can be of 2 byte also, can be of 3 byte also. So how that byte comes, that also we want to see. So for that, this is the topic that you want to convert your instructions from assembly language to binary language. This is what your task is. Clear? We are going to see the example of move instruction, MOV instruction. Okay. So for 8086, they have already predefined the value for your segment register. There are 4 segment registers. So 2 bits are enough. Yes, there are total 8 different registers: AX, BX, CX, DX, SI, DI, SP, DP. So 3 combinations are sufficient. So they have already created one table for 8086 which carries the value of each and everything. For register they have assigned the code. If it is AX register, the code is 000. If you are using CX register, the code is 001. So the code is already assigned. Understand? Yes. Now we have already studied addressing mode also. Yes. If I am saying move AX, 1234H, this is immediate addressing mode. Yes. If I am saying move AX, BX, register addressing mode. If I am saying move AX, square bracket 1234H, this is direct addressing mode. Yes. And if I am saying move AX, square bracket BX, this is indirect addressing mode. Even in indirect, you are in multiple layers. Square bracket BX, square bracket BX plus SI, square bracket BX plus 55. Depends on your requirement, you can use any of the indirect addressing mode. Yes? Yes. So there are different addressing modes also available. For each addressing mode also, they have assigned the code. Okay? Now how this code will be used, that will study. Clear? What is our target? What we want to achieve? We want to create binary code for our instruction. This is what our goal is. Clear? Now concentrate. They have already set the template. Okay, so using this template, you can convert any move instruction into binary. Clear? Now try to understand this template. Now 2 bytes are minimum requirement for move instruction. 2 bytes is minimum. Okay, so move instruction can be of 1 byte, it can be of 2 bytes or more than 2 bytes. Clear? So this is the full template. Now what it do? This is my opcode. Now we can't remember all the opcodes, so we'll assume that suppose 100100. This is my opcode for move instruction. We'll assume it is of 6 bit. We already know. In template, opcode is required of 6 bit. So suppose it is an add instruction, the opcode will be different. Understand? We'll assume that suppose the opcode of move instruction is 100100. This is a binary code we already received. So in exam, in case some will come and you need to write down opcode for this, you can write down, assume opcode for move instruction is this, and you can replace it over here. Get it? We are not going to mug up the opcode for each instruction. That is not possible. Then, so opcode is of 6 bits, so there is not a much concern. Then it comes D, direction bit. For right now, just assume that if it is from, you need to write down 0. If it is 2, you need to write down 1. Now what is from, what is 2, that will get clear when we solve the example. Just assume this. This is W, again a single bit. If 8-bit operation, 0, 16-bit operation, 1. Clear? Here, mode and RM. This is 2-bit, this is 3-bit. They are used to represent the addressing mode. That which addressing mode is used in your move instruction. Understand? So these 5 bits, these 2 and these 3 are used to represent addressing mode. And this is the registers which is involved in your move instruction. Understand? Yes. Now let's try to solve some examples so you will get it, what all this means. Suppose my instruction is move AX, BX. This is my first instruction. Okay? Now you first need to read this instruction. How you can read this? What instruction is transferring data from BX register to AX register. Yes? This is 8-bit operation or 16-bit operation? 16-bit operation because it is working with AX and BX. So this operation is of 16-bit. Then this is clear. And which addressing mode is this? So before jumping to tablet, you should know that also. Which addressing mode? Register addressing mode. It is simplest addressing mode. Two registers are clear. Yes. Now come here. Opcode, we'll assume that it is 100, 100. Then now DB is direction bit. So data is coming. Okay, we take AX as our register. Suppose. Okay. So data is coming from BX and going to AX. So 2 is equal to 1. So this D bit is equal to 1. Understand? Next is your W bit. This operation is 16 bit or 8 bit? 16 bit operation. So that is also 1. Understand? Now this D bit and this RAG bit are associated. So we have considered D direction of AX register. So here the code of AX will come. What is the code of AX register? You can see from the table. What is the code? 0, 0, 0. This much stuff is clear. Now this is addressing mode. Which addressing mode is this? Register addressing mode. For register addressing mode, what is the value? 1, 1. So your mode is 1, 1. Then, and which register is used in register addressing mode? AX is already covered. So which one is remaining? BX. What is the code of BX? 0, 1, 1. So now 1, 0, 0, 1, 0, 0, 1, 1 and 1, 1, 0, 0, 0, 0, 1, 1. This is the binary which is my actual binary of move instruction which your microprocessor will execute. Understand? Yes. And 2 bytes are sufficient? Yes, 2 bytes are sufficient. By seeing these numbers, it knows that first, using opcode, your microprocessor knows that you need to move data. Yes. By seeing D and W, it knows that you need to move 16 bit of data. Okay. From which register? BX register to AX register. So by addressing mode and everything, it will get to know everything. Understand? Yes. Clear? Yes. Try to make it a little bit complex. This one is easy, right? Sure. Again, concentrate. Now, if I am writing move CL, 55H, these are my move instruction. Yes. So first of all, try to understand what the instruction is doing. What is doing? Transferring data 55H to CL. Done? 8-bit operation or 16-bit operation? 8-bit operation. Because of CL. So this is 8-bit operation. Done. And this is which mode? Addressing mode? Immediate addressing mode. Okay? Done? Yes. Get it? Now you need to again make the code. For move instruction, suppose our code is 100, 100. Done? What is DB direction? Data is transferring directly to CL. So 2 is equal to 1. So direction bit is 1. Then what is W bit? It is 8-bit operation. So it is 0. Okay. Now this one is associated with RAG. Which register you are using? CL. The register is CL. What is the value of CL? 001. So it is 001. Okay. Now addressing mode. You can simply write down immediate addressing mode, but for getting the data, now it is not memory and not anything. So addressing mode they have not defined. You need to check the table. Okay. The proper table is given, so from that table you can get the value of immediate addressing mode. Okay. So you can write down that addressing mode 5 kilo over here. Now problem comes. What's the problem? Concentrate. By seeing this much thing, what your microprocessor can understand? Okay, Sorry. What your microprocessor can understand? You want to move the data. You want to move the data to CL. It is 8-bit operation, and you want to transfer immediate addressing mode. So some data is available. Understand? So your fixed code is available for instructions or registers. The numbers which are available inside your instructions are not by default available. Understand? So you need to mention it, that which data you want to actually transfer to CL. Understand? આજે 55 છે તમારે 8 બીટનો ડેટા કોપી મારવો છે CL માં એવું તમારા માઇક્રોપ્રોસેસરને આ 2 બાઇટ પરથી ખબર પડી જશે. બટ કયો ડેટા કોપી મારવો છે એને ખબર નથી. That you need to tell to your microprocessor. Understand? So I need to store this 55 also into my instruction. Understand? So I require third byte which contains 55H. If I write down the binary 01010101. Understand? Yes. So now this move instruction is of 3 byte. First 2 byte will tell your microprocessor that you want to transfer immediate addressing mode, transfer something to CL. But what you want to transfer, that you need to give inside your instruction. That is 55. So this is 3 byte instruction. 3 byte will go into queue, and that's why there is one direct line into your control unit, execution unit. If you remember the architecture carefully, there is one line which is going from your queue to execution unit. Why? Because you need to give this 55 to your execution unit. તમારા માઇક્રોપ્રોસેસરને એવું ખબર પડી જશે કે મારે CL માં કઈ નાખવાનું છે. એ શું નાખવાનું છે તે ક્યાં છે? ઇન્સ્ટ્રક્શનની અંદર જ છે. એટલે ડાયરેક્ટ જવું જોઈએ એક્ઝિક્યુશન યુનિટમાં. That's why that line is available, and that's why this 3 byte instruction. Initial was 2 byte, this one is 3 byte. Understand? For simple, those who don't want to get confused by all these things, numbers can't become as a direct symbols. You need to mention it inside your instruction. Keep in mind, whenever there is a number, you need to mention it inside your instruction. Clear? Yes. There is no specific code available. 55 no ek code hoy, 56 no ek code hoy, 57 no ek code hoy, you need to make infinite codes. That is not practically possible. So the whatever number comes inside your instruction, you need to mention here. Clear? Try to understand some difficult stuff. This one is also easy. Now, suppose my instruction is move a x comma square bracket 1 2 3 4 h. Okay, now this is my instruction. Yes? Concentrate. Now what this instruction is trying to do, transferring data from memory. Square bracket is memory. It can be anything from memory to AX. This is 8-bit operation or 16-bit operation? How you can say that? AX. That's why it is 16-bit operation. Clear? This is which addressing mode? Direct. Your address is given directly into your box. Clear? Now, write down this 6-bit 100100, right? What is D-bit? Direction is 2AX. 2 is equal to? 1. Yes? 8-bit or 16-bit? 16-bit. 1. Complete. Which register? Register? AX. What is the value of AX? 000. Here and here, addressing mode. Indirect addressing, direct addressing mode. Now this one is direct addressing mode. That is 0. No displacement. And here direct value. Direct value will come in 110. So that is 110. This much thing is O. Okay. After reading this much thing, what your microprocessor knows? You are using direct addressing mode. You want to copy some data from memory to AX, 16-bit. Done? But from which location? That is not given. So you need to give it. So you require 2 more bytes to store this address. 1, 2, 3, 4. Now this is a 4-byte instruction. Understand? Yes? But whatever I have written is wrong. Why? 8086 or all Intel architecture in that case is following Little Indian structure. We already studied. Yes? What is Little Indian structure? Higher byte goes to higher address, lower byte goes to lower address. Okay. Out of this 1, 2, 3, 4, which one is lower left side higher. These are my higher bits, these are my lower bits. Lower bits should go to lower address, higher bits should go to higher address. Here already given lower displacement, higher displacement. What is lower displacement? 34. Higher displacement 1, 2. So number will be stored like this. Understand? So this is my 4-byte instruction. So move instruction can be of 2 byte, can be of 3 byte, can be of 4 byte also. Understand? It depends on the instruction. Clear? Next. Chalo. Let's make it final, but a little bit difficult. So you can get all the idea. Final and एकदम final. चलो. Move CL comma square bracket BX plus SI plus 1122X. Okay. Now this is my instruction. Possible? Of course possible, right? That's evident. Okay, now first question. What this instruction is doing? Transferring data from memory, square bracket memory. Right now forget about which addressing mode. From memory to CL. Done? It is 8 bit or 16 bit? 8 bit because of CL. If CL is not available, you can use byte PTR, word PTR, assembler directly to know it is 8 bit operation or 16 bit operation. Remember? By default, there will be a register available, right? So it is 8-bit operation. Yes. Which addressing mode? Indirect addressing mode. Okay. This much thing is clear? Yes. Yes. Now constant. For move 1 0 0 1 0 0. Done. Direction is to CL. Yes. So we are not moved to Java. So all what we will do is from CL to this location. Okay. Now, so if it is from CL, then 0. 8 bit or 16 bit? 8 bit. Again 0. First byte is complete. Yes. Which register? Register. CL. What is the value of CL? 001. 001. Done. Now mode addressing mode. This is indirect addressing mode with displacement also. 16 bit displacement. Yes. Something with displacement. If displacement is of 8 bit, you need to use this. 16 bit means this. What is the value? 1 0. Something with 16 bit of displacement. Indirectly. Yes? If here you will get 11H, this is 8 bit displacement. Because I have written 1122H, it is 16 bit displacement. So it is 1 0. Understand? Yes. Indirect addressing mode containing BX plus SI plus displacement. Yes? So it is
0 0.
Done. There is a table available for addressing mode. There are total 32 addressing mode as far as 8086 is concerned. So you can refer that table directly and you can get these values. Just for simplification, I have written this. Clear? So this bit is also clear. Your instruction is over. If there is a number, instruction will not get over. Make it very clear in your mind. Yes? So I need to give which number? जो आटू आचीने खबर पड़ी जैसे कि you want to transfer data from CL to memory location where BX and SI will get added with some displacement of 16 bit and you want to transfer data. But what is the displacement value? Your instruction don't. So you need to give it. So there are 2 more bytes required which will store 11 22. Correct? Correct? No. Lower byte, lower address, higher byte. Now your microprocessor knows that this is your binary code. Clear? So this is how you can create binary code for move instruction. Same template for different instructions, and this is how you actually assemble your language into binary, and your microprocessor try to get that data. Same concept is applied in today's processor also. All instructions are having their template so that it will get converted to binary and you can execute binary values. Clear? Everything is done so fast and in the background, so we don't know, but we should know this. If you want to be a good engineer, computer software developers, you should know all this. Yes?
Yes.
Done? Okay. Thank you.